Hello and welcome to chapter 1 of geometry, guys. So I'm making this video on August, I think it's 3rd. I just got back from my a family vacation after my son got married and all this COVID mess, but it went really well. Good to see you. The notes, as stated in the getting started video, which was the first day. Hopefully you went through that so you don't have many issues here getting started. Are going to be puzzled. So you'll have some questions along the way that you answer. In order to get credit for those, you need to, number one, finish the whole video. I can see that. I get like timestamps and I can see what percentage of the videos you've watched. So don't just quit when the questions are done. You need to watch the entire video and you need to answer every question. If I look and I see that there's lots of stuff wrong, then it means you're not listening to the notes and I will contact you. Okay, so as of now, I'm assuming we're distance learning, that can change. So, but either way, this whole first chapter will be available via video. So we're going to get started. I'm going to share my screen here with you. So give me 1 minute. And here we go. So our first chapter, I'm going to move my face here. So let's put it at the bottom, huh? It's always good if you can still see me, makes it a little bit more personal, huh? So the first chapter is called Tools of Geometry. And if we are doing 100% distance learning, this does look like my classroom. I do have a Choose Your Attitude sign above my smartboard. I do a window right there that kind of looks like me. I made that one when my hair was a little straighter. Now it's a little curlier, but if you were to meet me in person, that's my best Bitmoji. But anyway, it's kind of makes us feel like we're in the classroom, correct? And so this is what we'll be covering in chapter 1. 1.2, we're going to do points, lines, and planes. Super exciting. Actually, it's easy, so that's nice. Then we're going to do some measuring of segments in 1.3. Some measuring of angles in 1.4, exploring some angle pairs and their different names and their different relationships in 1.5. We won't be doing 1.6. 1.7 goes a little algebra with some midpoint and distance formulas, and 1.8. 1.7 and 1.8 are actually the most important of the whole unit. But you can see, what's laid out ahead of you. As far as taking notes, I will have made that very clear in the getting started video how I want you to do that. A big chunky or grade, I'm going to try to make notes because it's kind of hard to cheat on them or use photo math or that kind of thing because you're taking notes. So I will have a big accountability for note taking. In addition to Edpuzzle, you'll be needing to turn in to me a copy of your notes. At this point, I'm working with different apps to figure out how to best do that, but I would have decided by the getting started video. I just noticed my hair's a little messy. Anyway, let's begin with 1.2, points, lines, and planes. All right, so for the points, lines, and planes, obviously, it seems like pretty standard. I know what a point is. It's a dot. That's true. The yellow dot right here is a point. We also have lines, okay? Points are considered to have no dimensions. Lines have one dimension, basically just length. And then we also have what's called a plane, which has 2 dimensions. All right, so if you're kind of in your room, the point is in the corner. The lines are where the 2 walls meet, and your planes is like an entire wall or the entire ceiling. And I'm going to refer to the room you're in quite a bit. So again, as far as note taking, this chart should be in your notes. If I say it should be in the notes, it means I'm going to be giving points for it. So you have a couple options. You can pause the video and actually draw it out, or there's a blank copy of a student version of the notes. You can certainly print this off and maybe cut it and paste it. That's sort of up to you right now. I will have given you all the options for note taking in the getting started video, so if you need to watch that. But if I tell you you have to have it in your notebook, you need to put it in your notebook. And it's up to you how you like to do that. All right, if you're a good drawer with geometry, you might just want to take notes all by hand. Anyway, so pause the video and be ready to make this chart. Once it's made, unpause the video. So the first thing we have is a point. Pretty exciting. This is called a point. In particular, it's called point A. How do you name it? With the letter. So if ever you see reference like this, means point C, find it. Oh, there it is. So points are pretty straightforward. All right, this next figure is a line. All right, you'll notice that these arrows at the end indicates that it goes forever in both directions. So you can't measure a line, it's immeasurable. I guess one could say it has infinite length, but a line you cannot measure. Now, as far as naming it, there's options. Sometimes how we name things in geometry doesn't matter, and sometimes it does. So it's kind of like, you know, with your name. If your name was Bob, wouldn't matter if somebody spelled it backwards, it's still Bob. But if your name was Trafalgar and they called you Traff, and you spelled it backwards, that's fart. Nobody wants to be called that. So with this line, there's a couple ways you'll see it named. Sometimes when it's off here like this purple, let's go to purple on my thing, it'll just say line L. And it means you're supposed to find the line named L. Now that's not an option over here because these are all points. We have point A, point B, point C, point D. So there's no option of naming the lines with just a single letter like that. But had there been a little M right off on the top here that wasn't attached to a point, we could call that line M. So this line over here, back to the one in reference over here, could be called line L. Most of the time, though, you'll be naming the lines with any 2 points on them, and that's where it doesn't matter which two. So we can name this, we can grab A and we can grab B, but you have to put the line symbol over it with arrows on both ends. Without that, it means something entirely different. If you leave one of the arrows off, it's entirely different. If you just put this over, it's entirely different. So you have to make sure you put that line symbol over the top or you will get deducted. But you can pick any 2 points in any order when you name a line. So line AB is the same as line BA. Neither one is measurable, so we can't talk about how long it is. Now, if I were to put another point down here, let's go put point Q. Then again, I can pick any 2 points in any order because when we have those arrows, it means you go forever in both directions. So line QA is exactly the same as line BA. Watch. Line QA goes through forever through A and Q. Line BA goes forever through B and through A. And because it goes forever in both directions, they're all the same. So again, when naming a point, a line, you pick any 2 points on it in any order, and you put a line segment over it. Now, one of the most common mistakes I see, especially we had in summer school geometry, we did distance learning, and one of the more common mistakes they would make is if it had 3 letters, they would pick all 3 and go like this. Now this has 2 mistakes, and I'd like you to stop and figure out what the mistakes are. The first one would be that we don't use 3 letters to name a line. We pick any 2. You could have picked A and D, D and B, A and B, it doesn't matter, in any order. Also, on the top right here, we need to make sure that we use the line symbol. So this, even though you might say, well, I know what I'm talking about, it's bad notation and you won't get full points for geometry. All right, so last over here, you'll notice I have 2 lines intersecting. If I asked you to name this one in green, again, you could grab any 2 points on it. I'm gonna say BC and put a line segment over it. That indicates that green line. Now in red, I can pick any 2 points on it. Suppose I pick E and A, and I can put them in any order, but I have to put that line symbol over the top of it. So this right here is line BC intersecting line EA, and all non-parallel lines will eventually intersect, and they always intersect at a point. So if I asked you, what is the intersection of line BC and line EA, you would say point C. All right, so any two lines that aren't parallel will intersect at one point. All right, so some important stuff here. The next step, this is called a plane. Now, the thing with the plane is you have to kind of picture it as well going forever in both directions. So, you know, we don't put the arrows on here like this, but it's kind of a surface forever. So like if you look up at your ceiling, it's like if it went forever across that slice of the universe at that height. All right, so to name a plane, again, you have two options. If there's just a P up here, notice that's not a point because there's no dot with it, then we could call that plane P. All right, but if that weren't there, then that's not an option. We can't call it plane B because B is a point. Okay, so the other option for naming it for any plane is you can grab any three non-collinear. So we're going to stop, and in your notes, I want you to put underneath your chart collinear, box it in. And again, if I'm telling you to do this in your notes, it means when I go through and give you a note grade, I'm going to be checking that. And because this is distance learning, you get to have that open note test. So that's going to be super helpful. Super helpful. Anyway, I haven't been teaching for a while. I actually, well, I have been a little bit because I did summer school, but anyway. If you had me in class, you know, I get a little goofy, I get a little off track, but it makes things interesting, right? So collinear points lie on the same line. Now you can see this word right here, line, and col means with. So the words kind of tell you collinear means on the same line. So collinear points are on the same line. Okay, and you can put that underneath your chart. So right up here, I would say D, C, and B. Again, I'm right over on here now. Let me go yellow so it stands out to you. D, C, and B are collinear. They're all on the same line, whereas D, C, and E are not collinear. They're not on the same line. Likewise, we have the word coplanar. So I'd like you to write that under the word collinear. And you can see it's written word, plane, co. It means on the same plane. So coplanar means you lie on the same plane. So I would say over here that points A, B, and C are coplanar. Now suppose, you know, kind of picture that thing floating in space, like a sheet of paper laying on those points A, B, and C. Now suppose I loft a point D above it. Now it's hard to do on this two-dimensional paper, but pretend D is like, okay, so here's the plane with A, B, and C on it, and then I loft D up here. D would not be coplanar with the other three because it's on a different plane. All right, so we have those words down. All right, so back to how do we name it? We name it either plane P when it has this letter right here, or we grab any three points in any order and we just list them. There's no symbol in front of it. There's no line over it. This is just plain ABC. Or I could call it plain C, A, B. Any three in any order lock you into a plane. Okay, now what you might say, what about P? P isn't a point. P is the name of the plane. So we have a little bit, you know, kind of, it makes, if that had a little dot under it there with P, then I could pick P, A, and B, or P, C, and A, or whatever. But I can't when that little green, just like over here, this line could be named L. Oh, darn it. There we go. All right. So also, two planes intersect in a line. So that's a little bit harder to draw, like how two planes intersect in a line. I'll try to do it for you here. Let's try a black. Let's go like this. Plane number one. And then let's do plane number two. Maybe coming through. It's really hard to draw, but kind of picture like two index cards. Like if you were to cut into them like this, you know, they would intersect at a line. Better yet is to take a look in your room and look up at where the ceiling intersects a wall. Like you can almost see it here in mine. I have some crown molding up there, but so you can see that I have the ceiling up here and then this back wall here, and they're intersecting along that crown molding or that line. So two planes intersect at a line, okay? So let's move along to the next page. Let's do a little practice. So again, for taking your notes, I don't really need you to put the practice in there. I just want the notes. If you want to, you can go ahead and then you'll for sure get full points. But for example, let's go back because it's our first day of notes here. If I say to put it in your notes, it means I'm going to look for it. I want that chart in your notes. This next example, it's up to you. You know, if you think you want to use it on a test, well, then have at it. So I'll tell you what has to go in your notes and what's optional. This is optional, but make sure you're listening. All right, so these notes are going to be a little longer than normal because it's our first one. What are two other ways to name line QT? Okay, so let's go over here and identify line QT. We go from Q through T forever in both directions. So remember what I said. I think my face might be blocking a little piece down here, so I'm gonna move it up. Remember what I said about naming a line. You can pick any 2 points on it in any order. So I could have picked N because that's on it, and I could have picked T because that's on it. This right here wouldn't give you full credit though, because again, it means something else when there's nothing over it that we'll talk about tomorrow, but it needs to have that line symbol over it. And we don't put 3 letters, we don't put 4, 2 to name a line. All right, do you think that might get asked in the ed puzzle? I do. Now also, because of this little M here, you could also just call it line M. All right, had that not been there, M isn't a point. Okay, it's off on the side. Now, those aren't the only 2 options, obviously. I could have said line NQ, line QN, TQ, QT. Well, I couldn't do QT because it's right, cutie. Thank you. What are 2 other ways to name plane P? Well, see, P isn't attached to a point, but it's definitely, consider that the floor. What other 2 ways? Remember I said to name a plane, you need 3 points on it, any 3 in any order. So I'm gonna pick R, and they have to be non-collinear. So I can't do RQS. RVS, those are my 3. RVS, nothing in front of it, nothing on top of it, there's a naked 3 letters. All right, what else could I have done? Remember, I can't choose L. L's the name of that line down there. It's not attached to a point. I need any 3 non-collinear points that lie on that yellow sheet of paper. So I'm not going to choose T, I'm not going to choose N, I'm going to choose Q. Doesn't matter. I'm going to choose, I can't do R and S. I should pause the video and ask an ed puzzle right now and say, why can't I? But for now, I'm going to keep this first ed puzzle really easy. And the answer is because those are on the same, they have to be non-collinear points. So let's take S off of there and let's choose B instead. Okay, so I could also call this R, Q, V. And I can put any 3 in any order. What are the names of 3 non-collinear? It means they're points that aren't on the same line. So non-collinear points could be R, and again, there's other options, but I could pick R, I could pick Q, I can't pick S though, because that's on line L, so I'm gonna pick V. What are the names of 4 coplanar points? It means they're all on the same plane. They're all on that yellow sheet of paper. R is on the yellow, Q is on the yellow, V is on the yellow, S is on the yellow. You can't choose P because it's not a point, it's the name of the plane. You can't choose L because it's not a point, it's the name of the line. I think you probably get how this is working here. All right, this must go in your notes. All right, so you either stop and you draw it, or you go to the student copy of the notes and you can cut it out and paste it in. Or if you're on an iPad taking them and you're just going to, write on it. Sorry, I have to adjust myself here. Write on a touch screen and then download as a PDF. I'll be pretty nice with how I accept them for this first chapter, and then I might tweak things as we go. So right here, you might say, oh, that's line AB. It's actually not. You'll notice it doesn't have those arrows. It's not going forever in both directions like this guy is. This is a line. And again, how do I name it? I just talked about that. I pick any 2 points on it. I'm going to pick C and B, and I put the line symbol over it. I could have picked A and B. I could have picked C and A in any order, any 2 points, not 3. Okay, now this guy up here is called a line segment. Now it is measurable. Lines and rays, not measurable. We can go ahead and put that on here. The reason we can't measure them is because those arrows indicate going on forever. All right, so we can't measure it. A line segment can be measured. How do we name it? It's finite in length. We'll talk about lengths of them tomorrow. But we pick the letters that are on the endpoints. So if there was a C in here, you can't pick C. Okay, you have to pick the endpoints. So you might even want to write yourself a little note and point at that and say endpoints. Okay, they can go in either order, and you have to put the segment symbol over the top. So you have to make sure that you, oopsie, didn't mean to make me bigger, I meant to move me. All right, or we could put B and A. So you pick the endpoints in either order with a segment symbol over the top of it. This sucker right here is a ray. A ray, you can't pick any points you want. Okay, this must pick the endpoints. For the line, you can pick any 2 on it. Because again, when we go forever through C to B and then B to C, we end up with the whole line. Okay, those arrows are really important. The ray, you have to lead with the point that does not have the arrow on it, the end point. And I like to go like that. All right, and then you send it forever through B with this symbol. Ray AB and ray BA are not the same thing. Ray AB is green. Ray BA is yellow. You'll notice they're not the same. Okay, now, erase, 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 erase. Let's put a C on there. Now, ray AC is the same as ray AB because they both have that same, I call it shout out point. I could have put a Q here, and ray AQ goes for A through ever through Q is the same as ray AC, is the same as ray AB. Suppose I put a little dot really close to A and called it W. Ray AW is also the exact same ray because it starts at A and goes forever through W. So with the rays, is if they have the same shout out point, they're the exact same ray. Okay, let's go to the next page. So again, it says, what are the names of the segments in this figure? Segments end, we have D, we have E, must have a segment over it. We have E, we have F, must have the segment over it. We have D, we have F, must have the segment over it, and they can be in the other orders. So I could have said ED. I could have said FE, okay? Segments, it doesn't matter. It just says start at D, end at E, go boom. It's the same as starting at E, ending at D, boom. So segments, you can be a little sloppy, but you have to have that symbol over the top. What are the names of the rays? Now I'm not gonna name all of them, but let's do ray DE. Now you might say, what's that one? That one starts at D, goes forever through E. Okay, it's the same as ray DF, right? But not the same as ray FD. It says, what are the names of all of them? But I'm not going to do FD, goes this way. So you have to make sure that this guy is where you put your pen and the arrow indicates go forever through that point. Which of the rays are opposite rays? Now this is going in your notes. So when I say it's going in your notes, you might want to pause. You might want to write opposite rays. Opposite rays do 2 things. They share an endpoint. So that's something I'll be checking in your notes. So you're going to get a score in your notes for this set. I'm going to look for that table. The first one completed, the second one completed, that you defined coplanar and collinear, and that you define opposite rays. All the examples I don't have you put in your notes. That's up to you if you want to. Some of them I'll say you have to do this one. But it's kind of, if you're a watcher, that's fine too. So opposite rays share an endpoint, or what I call a shout out point, if you want to call it that. but they also have to go in opposite directions, hence the word opposite. Share an endpoint and go in opposite directions. And go in opposite directions. And again, if anytime I'm writing too fast, you just pause me. That's kind of the beauty of the video, I guess. So what happens when rays share an endpoint and go in opposite directions is that they make a line together. So you might want to write yourself a note. They make a line together. Sharing an endpoint's not enough. These share an endpoint, but they're not opposite rays. Actually, those make an angle. All right, so let's go up here and name some rays that are opposite. EF. Now, I have to share an endpoint, so my next one has to start with E, and I have to go in opposite directions, so ED. These would be a pair of opposite rays. Notice they share the same endpoint, and they go in opposite directions, and they make the line. And again, I'm just doing one set. All right, so we're gonna practice using a box. So again, if you're a watcher, watch. If it helps you, stop, and you can either, again, cut and paste. I'd be really impressed with some of you with your interactive notebooks if you were cutting these out and pasting them in and used a bunch of highlighters, and notes are gonna be really important. There will be a box like this most likely on your test, so it'd help to have it in your notes, but it's not something I will dock you for if you don't. All right, so if you need to pause, go ahead if you're like, I got this. So these are the types of questions that'll be asked with this type of a figure. It might say, what is the intersection of now notice these are lines. Remember I said two lines intersect at a point. So when I go forever through A and B and forever through F and B, they intersect at point B. So AB and FB intersect at point B. So you might be asked about intersecting lines. You might be asked to name a point coplanar with a D. Let's say H. Now watch when I take A and D. And then the third point's the kicker because it locks you into the wall. So the minute I said A, D, and H, I'm locking you into this side wall over here. So the only other coplanar point, or the only other one on this left wall, would be point E. Okay? You might be asked, what is the intersection of? Let's see. Okay, now notice in green here, these three letters with nothing, that's a plane. So really what that means is I'm walking you into a wall. Like if this is your room that you're sitting in and you're sitting right here taking notes at your desk and blah, blah, blah. That's such a great artist, am I, right? When I say AEH, I'm locking you in to the left-hand wall over here. And remember, it goes forever, actually, it's a slice of space. And when I say GFE, I'm locking you into the floor. So when I ask you for the intersection, you'll notice that that left wall and the floor intersect down here. And let's go take a look because I at EH now. EH. What's wrong with that? And I'd like you to think about that. Think of why if you wrote that on a test, I'd give you half credit, but it's got bad notation because two planes intersect at a line. So you have to put the line symbol over the top of it. So again, you'll be asked things about coplanar on the same plane. What's coplanar with C, B, and F? C, B, F locks you into this right-hand wall, so it would be G. All right, you might be asked for the intersection of two lines. Lines intersect at points. So the intersection of DH and HG is point H. All right, and here's your takeaways to wrap this up. All right, so to end the notes here, let's see, it'd be nice if you paused this and you did it yourself, but through any 2 points, there is exactly 1 line. Through any 3 non-collinear points, there is exactly 1 plane. 2 lines intersect, should say 2 non-parallel lines, but we're just being picky, right? So 2 lines intersect at a point, single point. Remember what I said about those 2 planes again? Look at 2 planes, the ceiling and the wall intersect at that edge right there or at a line. So 2 planes, as long as they're not parallel, like here's a pair, the floor and the ceiling in your house are parallel, they're not intersecting. But the wall here or the floor and the wall over here intersect at this corner right there. So 2 planes intersect at a line. Remember what I said about those opposite rays? They have that same endpoint and in opposite directions. So visually, they make a line. These are not opposite rays. These are opposite rays. All right, can rays be of different length? No, remember I said they're not measurable. They have infinite length because they always go forever in one direction. Whether they look different, like these 2 right here up at the top in green, they look like they're different lengths, but this arrow means forever to the right, forever to the left. So they are not measurable. Can lines be of different length? No. Same thing, even if I went like this, you say, yeah, this guy's shorter. No, he's not, because it's going for, sorry, my nose itches. It means either it's gonna rain, which it kind of looks like that. Can you guys see outside now? You can't see. It's either gonna rain or I'm gonna get rich. I'm hoping for the rich, but if it rains, that's okay, then I don't have to water the flowers. Can line segments be of different length? That's a yes. The reason line segments can be of different lengths is because they stop and they're measurable. So these actually are very different lengths. This one looks to be about 1 centimeter, and this one looks to be about 3 centimeters. And you might say, yeah, it's the same over here. No, again, those arrows. Oof. All right, if one ray contains another, are they the same? It's a tricky question. I actually think it might be on your worksheet. If one ray contains another, I see, my nose is itching. If one ray contains another, are they the same length? If this was an always, sometimes, never question, it could actually be sometimes, because ray AB ray AC, you'll notice that AC contains AB. So if one line contains another, are they the same ray? You might say yes. But AB, this ray, also contains BC, this ray, and they're not the same because they have to have that same shout out point. So the answer is not necessarily or no. If one line contains another, are they the same line? The answer to that would be yes, because of those arrows going forever in both directions. The answer to that is yes. All right, so your assignment is worksheet 1.2. That'll be next up in Schoology. So hopefully those notes went well. Remember, there's 2 parts to the note taking. This is Edpuzzled. So as you're watching these, you should have been answering some questions. Then also at the end of the unit, I'm going to collect a digital notebook from you, and I will be giving you points on that as well. So actually the notes are more important or are worth more points than the homework is. So you guys have a good one. Hopefully this first set of notes went great for you. So I'm gonna stop sharing. I'm gonna say peace out. Look at that hairdo, yoza. That's the beauty of being at home. I can wear my Minnesota, so actually the North Stars, it's what the Wild was before they were the Wild. Super cool hockey team, and they had great colors. It's like this light green. Anyway, you guys have a good one.